I hope you all can see my screen. So the first topic we are going to discuss today is about DHCP. So we all know about this DHCP process a little bit, but let me give an overview about DHCP first. Let me fire up my whiteboard. So when this is a client PC and this is a DHCP server, and mostly the conventional design in the enterprise would be there is a switch and the users are connected to the cabins. There's a patch cable that's running from the switch inside the server room. So the user will be connected. They should have a wired connection here and they are connected to a port. And if it is a small office, they would have this local DHCP server setup. And if your DHCP server is somewhere in your remote site, example, this is your headquarters, and you have a switch, and you inside the server room, you have a switch and you got your DHCP server connected here. So your location will be connected something like this. So this is your branch office router, and they say this is an head-end router where you get your internet access. So example, this is a cloud internet and you are connected like this. So most of the deployment, they do this centralized DHCP deployment. Why it is quite easy? It's very, from the network engineer standpoint, this is pretty simple to manage. So management is very smooth when you do this centralized DHCP deployment, because I cannot have a DHCP server in every location. So this is one location. So example, you got one more location somewhere here. This is your remote office, and you got your router and same kind of setup. You got a switch and you got the DHCP server connected here. So this is all local. This is all local servers. So here, what we are going to look at today. So how exactly the DHCP works, and through Wireshark, how do I capture those packets? Yeah. So it can be done either way. Either you can do from the switch or from your PC. So example, if this is your PC, this is the PC, and you have your network interface card, we call it a NIC card, where all your traffic is going to the switch and all the way back to this DHCP server. So imagine you have your DHCP server, local DHCP server here in the switch. And if your communication is happening between this PC and your DHCP server. So the PC is going to send a DHCP broadcast. So we call this as a DHCP discover. If you look at the IP header, it's all zeros. If it is all zeros, it means everything. No limitation with the network. It's broadcasting out. And your subnet mask will be 255.255.255.255. Why you're going to this level? Only then you can find out the DHCP values, and you can differentiate the discover packet, offer packet. So to make the differentiation, you should be aware of all this. So your packet form is it looks similar to this in the DHCP broadcast, and now the DHCP broadcast has been sent from the PC to the DHCP server. So what if I send a DHCP broadcast and I'm not getting a response back from the DHCP server? How do I find that? Only with the PC, if you do a DHCP discover, you will never find anything out of it. All you can do is DHCP release and DHCP renew. That is something I'm going to flush my IP and I'm trying to discover back again. This is DHCP renew will initiate this DHCP broadcast packet back. So this two communication happens with the command line in your PC. In your command line, you can do IP config / DHCP release and DHCP renew. In your IP config, you can do DHCP release and DHCP renew. So only this is the limitation I have with my PC, and I can do it. So if I'm not getting a DHCP, how do I find it's a problem with the client or it is a problem with the server? So this is when the Wireshark comes in. So we'll see how we can figure out, is it a problem with the DHCP server or it's a problem with client? So for that, let me open up the DHCP packet capture. Okay, so here you can see my source address is all zeros. My source IP is all zeros and my subnet mask is all 255. So if I go a little bit right hand side, I can see the communication here. The info, it says it's a DHCP discover. So it always happens from the client. This is your PC, your DHCP discover will be from client. So now let's drill down inside the packet. See, DHCP stands for Dynamic Host Configuration Protocol. So your client IP address at this point, it is all zeros. And if you see the boot flag, this is unicast. So we'll get to know about all these details because of Wireshark decoding. So you can see the list of options here, and the main options, what we should focus here is what is the client IP at this point? This is all zeros. And this is a DHCP broadcast. Can you see this is our DHCP broadcast, and this is, we say this is L2 broadcast. So all F is an L2 broadcast here. So this is done. So now the client, it sent a DHCP discover packet. It's a broadcast for everyone. So whomsoever in the network, they are interconnected inside the LAN. Yep, this is how exactly the DHCP process works. This is your switch, and you have many clients connected, and you have your DHCP server here, and the DHCP protocol is enabled in the server. And this is all clients. This is all client PCs. So from this client, the DHCP discover is broadcasted. It goes to all the clients in the network. This broadcast goes to all the clients in the network. But the DHCP server will respond back. Why? Because I have created a scope. We call this as a segment. Example, all this PCs are in this particular IP range, 10.0.0.0/24. Yeah, this is my subnet mask and this is my IP details. So I want to get an IP from this range. So what should I do here? So inside the DHCP server, it should have the IP parameters. What are the IP parameters it should have? It should have a scope for 10.0.0.0/24. So it's going to define, okay, my IP is 10.0.0.1.1 to 254, and 255 is my broadcast. So 10.0.0.0.255, this is a broadcast address. So it starts from 10.0.0.1 and it ends with 10.0.0.254. So you got 254 address inside this scope that's configured here. But now the question is how this client knows where the DHCP server is. Whenever the DHCP request it goes, it actually, we call this as gateway address. When you send a broadcast, so for example, all these clients are connected to this switch, and this switch is the gateway for all the clients. And my gateway has been configured as 10.0.0.1. So what happens, all this broadcast, it hits the default gateway. From the default gateway, the packet will be traveling back to the DHCP server and it look for the scope. Okay, it matches my network and I got a scope and I got an IP address, and it picks an IP address from here, a random IP address from here, and it will reply back to the client. And now the client gets an IP address. Now the client gets an IP address back from the DHCP server. So this is the offer packet where if you look into this, you will see this is boot reply. This is a reply from the server. This is an unicast again. Even at this point, the client IP address has not been assigned, and it's giving an IP address 192.168.0.10 because this is my PC, and the broadband, it uses a class C address. This is a class C address. There in the example, I have given a 10 network. So this is a class C address, and it says this is your next server IP address. And you will see your MAC address details. At this point, it's saying that, okay, if you are okay, you can get this IP details for you. Even at this point, the client has not been assigned with this IP address. It is just offering this IP address to the client. So you can see all this information inside. So now the server has been successfully sent the IP address to the client. Right? So request is again from the client to the server. This is again a boot request. And if you drill down, if you see the client has not gotten any IP address details. And if you go back to the DHCP acknowledgement, here actually the PC, it gets an IP address. So now the client got an IP address. So this is called as a four-way handshake. So why Wireshark is needed here? So if there is a problem between a client or a server, I can figure out. If I see the DHCP discover and if I am not looking any DHCP offer packet, then I can conclude that it's a problem with the server. So this is a real advantage of using Wireshark for DHCP process. So if there is any problem irrespective of anything, if you're not getting your DNS details, if you're not getting your DHCP IP address, you can figure out where is the problem. It is a problem with the client, or it's a problem with the server, or it's something with the scope. Yeah, this is just a glimpse about how DHCP works. This is a demo class. So in the real classes, we'll drill deep and we'll do a deep analysis about every single parameter of DHCP in Wireshark. So this is all about DHCP process. So now let's jump on few filters. So example, if I don't want this particular destination IP address in my packet capture, how do I do that? So this exclamation stands for not, and this is IP.destination equals and your IP address. This is something I am not interested to look at any kind of conversation that's happening for this particular IP address. Let me copy this filter and let's assign this. So if you actually see, if you drill down, you won't see this IP details 192.168.10.185. That's the meaning of this. So IP, whatever the IP with this destination, this particular IP, I'm not interested in. I don't want to see any kind of conversation for this particular IP. So this is the use of not operation and followed by your IP assignment. So if you give IP.source, you will not see any source address with the parameter. Whatever the IP address you want to give, if you give here, it will filter out all the IPs with the source address. Now I have given destination. So this is one filter. The real classes will see 100+ filters that can be applied based on your issue. You can figure out what exactly needed. You can filter out all the other details, and you can look at exactly what exactly needed for a particular issue. You can filter out if you tweak your Wireshark filters. So next thing, what is ether type? About ether type, you maybe in many interviews I heard, and even I've been questioned about what is ether type, what is the use of ether type, and why we use ether type. Ether type is very important because when you look at this is a little bit of overview about the OSI model. We are not going too deep about OSI. Just for this ether type, I'm going to give a little bit of background about ether type. So when you look at the last layer, it is physical layer. So after that, here you got network layer. This is layer 2, where all your MAC address. So this is called layer 2, right? This is called data link layer and layer 2, and this is your layer 3, and this is called L1, all signals. You get only the wire connections connected. It's all understand about the signals, nothing else. So when you look at this data link layer, it's all about MAC address, right? Destination MAC first, example CDE4, for example, and your source MAC is something similar to BCDE. So what is ether type and why I need to know about ether type? So ether types defines what is my next packet. Is it an IP packet, or it is an ARP packet, or it is a DNS? So when you do a troubleshooting, so where the problem is it my DNS communication is not happening, or if it is my ARP communication is not happening, or it is something problem with IP? You have no clue. If you do not have any, if you're not capturing the packets, you'll never get to know about all this. But with Wireshark, if you go back here, and if I take any IP address here, you have to click on any IP. Inside the internet protocol, you have the ether type, but it's very hard to find, right? So it's very hard to find where is my ether type. So there is a filter in Wireshark where you can find the ether type. So if I copy this, this is not equal to ether type 0/0x0800 for every, as I said, for IP, there is a different ether type value. For this is 0x0800 is the ether type for IP. So if I want to filter only this, if I want to filter only this ether type, only the IP packet, I can use this. So this is all the IP packets I got. So ether type, you can filter all the ether types with the help of this filter. Ether type is all IP ether type. For ARP, you have a different ether type. And so in the real class, you will see how if a DDoS attack is something, if they do a continuous ping to your PC, that is choking your bandwidth, they will bring down your server. Example, if you got an environment where you have multiple clients connected, and somewhere from the internet, an user, he's trying to do this DOS attack. It's a continuous ping attack they do to bring down this server. They can do this with the DOS attack. So with the help of Wireshark, with geo IP configuration, you can find out where you get a list of hits. What is the IP range and from which location, from which country you get this attack. You'll get to know about all this in the real classes. We have a topic to be discussed for this, how DOS attack is happening and how can I find with Wireshark. I'll just show you how it looks. So for that, you have to install a application is a GeoIP, and we can configure the Wireshark to utilize it, and you can find out, okay, where is my IP it's coming from the scan map. And you can find, okay, this is a list of IP range, and this is the location, this is the country I'm getting hits from. So you will get to know about all this. We have a lab for it. And this is how the Wireshark works. When it comes to, if they do a vulnerability analysis, and if there's somebody is trying to do an attack, you can find attacks. And this is one demonstration we have in the real class. We'll see how this DOS attack is happening and how do we figure out that, and how with the help of Wireshark, how you can find out where to find and how to configure. Since we had a long discussion yesterday, I just want to give a glimpse about some of the topics in Wireshark. So now